Alright, we've got a question here. Given the function c equals q3 minus 4q squared plus 10q plus 75, determine the marginal cost function. So the marginal cost, this is just the additional cost you incur whenever you produce an extra unit. Okay. So in this question here, we have to derive, this is our cost function, you have to derive it to get the marginal cost function. Okay, so it deals with the power rule. Let me just get this. All right, so let me derive. So we've got c q cubed minus 4q squared plus 10q plus 75. So the marginal cost, derivative of the total cost function. So what you put like this: you're deriving the cost function dc with respect to q. This notation just says that this function that we're deriving it, the letter we're focusing is on is in q. So we're using the power rule. Okay, you multiply the power with the coefficient, the number in front of the letter. If a letter hasn't got any number, assume that that number is 1. Okay, so like this q cubed, it's like 1q cubed. So 3 times 1, that is 3. And you put here q. And always remember, as you derive, you subtract a 1 from the power. Okay, so 3 minus 1, that is 2. 3q squared minus, we do the same thing again, multiply the power, 2 times 4, that is 8, subtract 1 from the 2, 2 minus 1, that is 1, plus 10q to the, this q is to the power 1. Okay, 1 times 10, that is 10. Subtract a 1 from this power, you have 10q to the power 0. But remember, anything to the power 0 is 1, so you don't even need to write 10q to the power 0. And if a number doesn't have a letter or a variable in mathematical terms, if a number doesn't have a variable, it just disappears. Okay, so that is our answer. 10q. Any questions? So this is our marginal cost. All right, so if you produce an extra unit, you just put 1 into the, substitute q with 1, and that will be your extra cost for producing one more unit. Okay, so produce one more extra unit, substitute q with 1, and whatever value you get, that is your extra cost. Any questions? Mr. Chipipa, Madam Prudence, any questions?
So the power is just have to know, like you multiply this, the cube number by
the power by the number in front of the letter.
Yes, then you subtract what's on top.
You always subtract a 1.
Okay.
All the time.
Alright.
But
if the letters were different, it was like maybe 4D minus 4q plus 100.
Then that's where partial differentiation comes in.
Partial, okay,
Yes.
okay.
Partial differentiation is when you've got two different variables. Here we've only got one variable, one letter, so you can use typical differentiation. But now if you see two other letters, that should tell you, okay, now partial differentiation. Or three other letters, partial differentiation. That's where it comes in.
Okay. So the only two others is the power and the partial.
There's also implicit differentiation also. Okay, that one has also got, that one also deals with I believe two more. So you just look at, because in economics they'll give you these functions, so you just look, okay, what is the variable? If there's one variable, you just know that you're using normal differentiation.
Okay.
Okay, then we've got question 2 here. Given an average revenue function AR equals 15 minus Q, derive the marginal revenue function. Okay, so colleagues, here also you have to remember these formulas. Okay, if you remember from microeconomics, average revenue equals total revenue over Q. Okay, because this question has asked for the marginal revenue, so what it should tell you is that you need to get your total revenue. Okay, because they've asked for marginal revenue. All right, marginal revenue is the first derivative of the total revenue. And remember, marginal revenue is the additional revenue you get when you sell an extra unit. Okay, so here our average revenue function is 15 minus Q equals TR, total revenue, over Q. So to get our total revenue, we need to cross multiply. Okay, so total revenue is going to equal to, from this formula here, total revenue is just average revenue times quantity. So we're multiplying this average revenue by this quantity. Okay, so it's like Q times 15 minus Q. Q times 15, Q times 15, that is 15Q. Q times Q, that's Q squared. So now that we've got our total revenue function, we can get our marginal revenue function. Okay, colleagues? So marginal revenue is the derivative of total revenue. Okay, remember, differentiation is just about how something changes, a rate of change. Okay, it's a rate of change. So we derive 15Q, this is like Q to the power 1, 1 times 15, that is 15. We subtract a 1 from this power, 1 minus 1, that is 0. So Q to the power 0, that is 1. Minus Q squared, we say 2 times Q, that is 2 times 1, that is 2. Then subtract a 1 from the power, and we have Q to the power 1. Okay, so our marginal revenue is 15 minus 2Q. Any questions? Find the point of elasticity of supply Ls from the supply function Q equals P squared plus 7P and determine whether the supply is elastic at P equals 2. So price elasticity of supply is how quantity supplied responds to changes in price, okay? How quantity supplied responds to changes in price. That is price elasticity of supply. So when they say here point elasticity of supply, this is the formula you're going to use. The derivative of the supply function, so we say dp over dq was deriving the supply function with respect to p. Then we're going to multiply this by our price over our quantity. Okay. So we're going to derive this and multiply it by the price over the quantity. So first things first, let us find the quantity. They've told us the price equals 2, so let us find the quantity. So we're going to say Q equals P squared plus 7P. We substitute P with Q. So P, that is 2 squared plus 7 times 2. 2 squared, that is 4. 7 times 2, that is 14. 4 plus 14, that equals 18. Okay, that equals 18. So we found Q and we know P. Now next what we need to do is we need to derive. So we derive our supply function with respect to P. So let me write it here again. Q equals P squared plus 7P. Alright. So we need to derive. So using the power rule, multiply the exponent 2 times 1, that is 2. Just hold on for a minute. Two times 1, that is 2. Subtract a 1 from this. Two minus 1, that is 1, so we have 2P plus, when we derive 7P, it just becomes 7. Alright. This is our derivative. Then for our derivative, we need to get a number. So remember, P still equals 2. So substitute that into our derived function. dq over dp so when you substitute 2 here with p, we're going to say 2 times 2 plus 7. So 2 times 2, that is 4. 4 plus 7, that is 11. Okay. So now we've got all the values for our formula, which is here. dq over dp multiplied by p over q. So dq over dp, we derived it was 2p plus 7. Then we substituted the 2. We got our answer as 11. So we're going to say, let me just write the formula again for this. dq over dp times price times over quantity times p over q. Right. So dq over dp, that's 11 times p was 2 and q was 18. Alright, so what we're going to say is 2 divided by 18 divided by 18, that is 0.111 times 11, we get 1.22. Our price elasticity of supply, PES. So how we interpret this? If your price elasticity of supply is greater than 1, if PES is greater than 1, it means supply is elastic. What we mean by elastic? When we say supply is elastic, it means it responds greatly to changes in price. So price can increase by 1%, you find supply will increase by maybe then 20%, 15%. Price can drop by 1%, you find supply will drop now by 30%, 20%. Okay, because once supplied is it responds greatly to the changes in price. That's how we translate this 1.2. If this is greater than 1, it tells us supply for the good is elastic.